Hi, I'm David Gristwood from Microsoft, and I'm with Richard Prodger from Active Web Solutions. We're in the Microsoft Technology Centre here in Reading in the UK, and we've been working on some quite interesting stuff. So Rich, before we get into the specific of this global alerting platform, tell us a little bit, well, refresh the memory of the RNLI project, which really lies at the roots of this.
Yeah, sure. We were involved with Azure back in the early Red Dot days, prior to its release in PDC 2008.
That was a long time ago.
It seems like forever, yeah. And at that time, we built a proof of concept in Azure of this search and rescue system we built for the UK Lifeboat Service. And that was an on-premise system which we migrated to Azure because they wanted to understand how they could address the scalability issues of taking that particular sea safety device to a wider market. And basically, it's a box of electronics that got installed on a fishing boat, and a fisherman wears a wireless pendant. And if they fall overboard, it sends a message via satellite, via the Iridium satellite cluster, down to a ground station. We pick up that message and then raise the alarm with search and rescue, and then plot that on a map essentially for them so they know where to go. And so we ported that from on-premise kind of Windows Server and SQL Server behind the scenes, rich .NET client, desktop application, and we pushed all that stuff into the cloud. And as a result of the work that we did on that, we built that proof of concept, and we started to gain an understanding from the satellite community that the number of individuals out there who wanted to carry a personal navigation stroke tracking device was increasing enormously, particularly in the kind of lone worker safety tracking kind of scenarios. And Iridium themselves...
So this is the system of, what, satellites?
The satellites, yeah, sorry. Iridium is the only provider of a truly global satellite network. They've got 66 polar orbiting satellites up at about 780 kilometres up, and they cover the entire globe pole to pole. They're the only provider that does that. And they've just recently, in the last 12 months, brought out a miniaturized version of their satellite modem, which allows manufacturers to build handheld satellite communication devices, text-based devices. We're not talking about sat phones here, but to build text-based devices.
This is about alerting, isn't it? This is not just generally having a chat.
No, it's not about chat. I mean, but you can use this technology for doing simple text messaging in two directions. I mean, in the marine world and in the search and rescue world, there have been devices around for a long time called EPIRBs, emergency position radio indicating beacons, which use a set of satellites up there that if you press the button on one of these beacons, it just bleeps and the satellite picks up that message, and some of them have GPS built into them. But there's no message coming back the other way. You never know whether the search and rescue services have ever received that message. Typically these devices can lay dormant on a boat or in a van or wherever, or in your backpack for several years. When you come to use them, the battery's dead and so on. One of the key things that Iridium are promoting, and some of the other vendors are promoting, is the ability to be able to message back to that individual who may be in trouble. So you can not only validate the alarm and determine whether or not that guy really is in trouble, or whether he's actually just pressed the button by mistake. You don't want to send an aircraft carrier and some helicopters to pick somebody up if they've just run out of beer and pressed the wrong button. Okay, so the search and rescue services are very interested in having the ability to be able to communicate that information back. The emergence of these new miniaturized modems has meant that device manufacturers can start to create handheld two-way satellite-based messaging devices that will work anywhere on planet Earth. Anywhere that you can see the sky, you can now communicate, so you don't have to worry about being in terrestrial communication anymore. You can now communicate globally, and devices such as this is a first version of a device that uses the satellite modems, and new versions and smaller versions are coming out of this device. You can send text messages just not as you would from a mobile phone, backwards and forwards between devices and back between other systems. But the other nice thing about these devices is that they carry an emergency button. So here we have an emergency button. If I press that emergency button now, then a message would get sent and then routed through to the appropriate endpoint, whether that was an emergency first responder or a search and rescue center. There's one thing just to have just the devices really, but that's only half the story. I think one of the key things here is that what the manufacturers and vendors of these devices require is some highly available, highly reliable back-end services to guarantee that once the satellite message hits the ground, that it's going to get routed through to its ultimate destination. So our response to that requirement really was the creation of GAP, or our Global Alerting Platform, which is an Azure-based infrastructure that receives the messages in from a variety of different devices. In fact, we're not limited just to Iridium-based satellite devices. We're actually completely device agnostic. We've got a pluggable architecture that allows us to support, as you can probably see in the diagram here, a whole range of devices. Any device that's capable of electronically reporting its position, really, we can use on the platform. And then we store all the data and then route all that data to the appropriate endpoints once it reaches us. And so down here on the bottom of the chart here, you can see there's some examples of some applications that you can then build on top of that platform. So whether that's a search and rescue application, which we have here, which uses marine mapping as a rich client, or whether it's a WinPhone 7 or a web app, or indeed an Outlook plugin. Just to show you an example of this working, up here on the screen we've got just got Outlook. That plugin that I showed in the last chart has been added into Outlook 2010 here. So Dave, if you just double click on one of the emails, this is an example where the satellite message has come into our platform and then we've just routed it on to an individual, me in this particular case. We're not doing anything else with it. And what this plugin does is it decodes the original GPS information and other data about that report that came in from the device, and we've incorporated Bing Maps into the plugin. So by default, it gives you a location of where that device last reported on the system. So it's a very simple application. You receive the message, you don't have to go to another website and log in.
So clearly, Azure makes a fantastic platform. It gives you that global presence you need. So talk us through how you sort of handle the architecture behind this.
Okay. I mean, I tried to sketch up here a simple slice through. So over up here on the left-hand side, let's assume we have an emergency or text messaging device, satellite-enabled messaging device. It sends its messages up to the satellites. As we said before, it could be any satellite cluster that's appropriate for that particular device. Those messages come down to a ground station, okay, and that ground station can be anywhere. In the case of Iridium, it's in Arizona. And then we take a direct IP feed into an Azure worker role, okay, or more than one worker roles.
Okay, so this is where we're getting the scalability.
So
this is where we enter Azure.
Absolutely. So this is the point where we enter Azure. So we expose an endpoint here, which their satellite ground infrastructure can talk to, and they pump the messages into the worker role. So the first thing that we need to do is we then need to figure out what device that's come from, what type of device it is, and so on and so forth. But the first thing, before we do that, we want, for scalability, we want to start to partition this out. So we split out those messages and stick them onto queues inside Azure.
So you're using the classic async model here of persisting these out.
That's right, for work distribution, because there potentially could be hundreds of thousands of messages coming in here and in rapid succession.
So you need that
so
rapid response.
we need to be able to chuck these hot potatoes somewhere before we deal with them. So we put them onto some persistent queues. So, and you put the data onto the appropriate queue based on the type of message that came in. So we look at the header of the message and say, it's from this device or it's from that device, and we stick it onto the appropriate queue. So we distribute these messages out, and then monitoring each of these queues are what we call the message processors. So this message processor here understands the message type that's come from that device, because that queue is specific for a device type, okay, and there may be thousands of messages coming in for that device type from different subscribers. And this message processor then analyzes that, decodes the original satellite format data, and then pushes that message onto another queue for subsequent processing. So we would have more than one of these queues per device type.
So this is your scaler?
Yeah, and more than one potential message processor for different types, but we can have multiple instances of the same message processor to deal with larger volumes. So if this thing starts to get swamped and this queue length starts to get long, we just instantiate some more message processors of that type to handle the dequeuing of those messages. So assuming the message has been processed, we now know who it's for, where it came from, and what we should do with it. We stick it on a queue for subsequent processing, and then we have some message routers that pick that up and say, this is a message from Richard on this device going to Dave on this device. Okay, so that message router then, if it's going back to your device, it would then stick it on another queue, which would then be processed and send it back to another. Yeah, or it might go out to the email, as we saw.
So that was a gateway outside of Azure.
That's a gateway outside of Azure, or to a telco SMS gateway to route that message on. There are some other elements of the system, but in simple terms, that's how it works. And then over here on the right-hand side, all of the data is stored in a combination of the table storage, blob storage, and SQL Azure.
So how do you choose to balance between the different types there? Because you talked about the core Windows Azure storage, and of course SQL Azure as well.
We use the table storage for the majority of the storage of the data. We use the SQL Azure for some of the relational data around the end users, their profiles, registration data, and so on and so forth. And sitting on top of that is our API, and then the application, some of the applications that you saw earlier that we've built talk to that API to pull that data out and handle the interfacing to things like the routing and so on. So this has got things like address tables in it, and the canned message lists. It's got the inbox tables, and the messages outbound and so on and so forth. They're all stored in there. With the Iridium style messaging devices and their satellite modems, because you can do it in both directions, the market is just waking up to the value of that. And some of the figures that we've seen, we expect to see hundreds of thousands of those devices starting to appear on the market over the next couple of years or so, as the manufacturers embrace this new miniaturized modem. So what this infrastructure provides us is with the ability to provide those value-added manufacturers with an out-of-the-box, scalable and reliable back end that can deliver the messages from their devices. They haven't got to worry about the provisioning of this infrastructure themselves. We can do that. We'll charge them a small fee for having that device on our system, and they can worry about concentrating on the devices themselves. And we can build custom line of business applications to suit as and when they need them.
So in a short space of time, I'm going to be able to go into some hardware store, buy one of these devices, set up as a subscription for it. I can go out in the mountains or sea or whatever it is, confident the fact that if I press this button, no problems. It's going to be routed somewhere where someone's actually going to do something.
Absolutely, and your message will come through here. Yeah.
Excellent. Thank you very much indeed.
That's a pleasure. Thanks.